Alrighty, these are the answers to your number skills test. So go through this video, note your mistakes, and write them down somewhere, and reassess at the end of the holidays. See if you can do the problems now, see if you've learned something. So these are the answers. So evaluate the following using an algorithm or otherwise. So you don't have to use the algorithm, but for many of you that will have been the easiest approach. So I'm just going to assume that many of you did use the alg and do it that way. So 7 and 8 is 15. So write down the 5, carry the 1. 2 and 4 is 6, plus 1 is 7. So the answer is 75. Okay, so this one is 345 and we're removing 67. We can't remove 7 from 5, so I'm going to exchange one of the 10s into 10 ones and do 15 take away 7, which is 8. 3, or can't remove 6 from 3, so I'm going to grab one of the hundreds and exchange it for 10 10s. So I've got 13 10s take away 6 10s, which is 7. 2 take away 0, which is 2. 278 is the answer. 4 lots of 120, 4 lots of 100 is 400, 4 lots of 20 is 80. So that's simply 480. This one here, 364 by 21, probably lends itself to an alg. 4, 6 ones are 6, 3 ones are 3, 4 twos are 8, 6 twos are 12, carry the 1, 3 twos are 6, plus 1 is 7. 4, 6 and 8 is 14, so write down the 4, carry the 1. 3 plus 2 is 5, plus 1 is 6, 7. So the answer is 7644. Okay, some division where the remainders needed to be as fractions. So we're going to put 4 into 712. 4 goes into 7 once, with 3 left over. 4 goes into 31 7 times, with 3 left over. 4 goes into 32 8 times. So the answer is 178. 5 goes into 576. Well, 5 goes into 5 once. 5 goes into 7 once, with 2 remainder. 5 goes into 26 5 times, remainder 1. But we needed to give the remainders as fractions. So it's 515 whole times it goes in. We had 1 left over and we were dividing that by 5. So 115 and 1/5. Okay, this one required rounding to the nearest hundred. So we look in the hundreds column and we look to the number immediately to the right of it. If it's 5, 6, 7, 8, or 9, this number goes up by 1. So the answer here is 7700. Okay, this one here is the leading digit, which means we're looking at the first digit there. We look to the right immediately, or the number immediately to the right of the first digit. And if that's 0, 1, 2, 3, or 4, we simply chop the end off and replace with zeros. So this is roughly 300 to the leading digit. Okay, order of ops to answer or find answers to the following. So this one here, we've got to do the addition first. Okay, so it's 27 take away 10, which is 17. This one here, we've got no choice. We've got to do the brackets first. So that's 3 plus 5 take away 2 is 3 times 7. Now what we've got to do is the multiplication next. So it's 3 plus 3 sevens are 21. 3 plus 21 is 24. This one here, what we're going to do is evaluate the index. So that's 10 take away 9 times 6 divided by 27. Now, what are we going to do first? It's the multiplication moving left to right. So it's 10 take away 9 times 6 is 54 divided by 27. Now we have to do the division, and it just so happens that 27 goes into 54 2 times. 10 take away 2 is 8. So you could do a factor tree or factor ladder for the following number, 168. So let's do 2 multiplied by, what is it, 50, 80, 84, I believe. Let's just quickly check that. So 2 into 168, 0, 8, 84. Yep, 84. Okay, now I'm going to do 2 and 42, 2 and 21, 3 and 7. Okay, so that's the factor tree version. Not many of you seem to use the ladder, but those who know how to use it, you would have just done 2, 84, 2, 42, or something similar. 2, 21, 3, 7, and then those numbers form your prime factors. So use your factor tree result to write 168 as the product of the prime numbers. So 2 times 2 times 2 times 3 times 7 must equal 168. So it's that number, that number, that number, that number, and that number. The prime factors equals 168. Many of you express that as an index, which is fantastic. Didn't have to, but that's good. Okay, the multiples are the times tables of a number, and what we're talking about here is the first 5 positive multiples. So the first positive multiple of 12 is simply 12, because that's 12 times 1. Next one's going to be 24, because that's 12 times 2, 36, 48, 60 is the first 5. The first 5 multiples are 9. 9 will be the first one, followed by 18, 27, 36, 45. The lowest common multiple is the lowest number that they have in common, which it looks to be those two numbers there, 36 and 36 is our answer. Okay, the factors of 15. Okay, so 15 is our number. 1 times 15, 3 times 5. Loop around, 1, 3, 5, 15 are our 4 factors. Okay. Right, 45, 1 times 45, 2 doesn't. Okay, does 3 go into 45? Well, yes it will, because if we do the divisibility by 3 check, 4 plus 5 is 9, 9 is divisible by 3, therefore 45 is divisible by 3. How many times does it go in there? I'm not sure. 3 goes into 4 once, 1, 3 goes into 15 5 times. So 3 by 15 is 45. 4 doesn't, 5 certainly does. 5 nines are 45. 6, 7, no. 8, no. 9, yes, but we've already done this. All right, loop around. Follow that loop around, and you got 1, 3, 5, 9, 15, and 45. All right, now we're looking for the highest common factor, which looks to be 15. Okay, Lily shows rounding, or uses rounding rather, to estimate the answer to this. She got 320,000, and what did she use? Well, this will involve a little bit of trial and error, but what I'm seeing here is this could be rounded to 1600. 1600, that's half, 16 is half of 32, so are we willing to bet that 1596 was rounded to 1600, so rounded to the nearest 100? That means 200 lots of it. So this one here would have been rounded to the leading digit. So 240 would have been rounded to 200, to the leading digit. 1600 times 200 equals 2 lots of 16 is 32 with 4 zeros. 1, 2, 3, 4. Does that match? Yes, it does. So these are the two values that you needed to find. All right, Carla adds these two numbers together by adding 200 and 100. So she would have got 300. This means 200 is 4 over that. 100 is 5 over that. There. So she's gone over by 4 and 5 in total. So has to remove 9 to get the exact answer. Okay, the difference between these two numbers here, well, probably using an algorithm would be a bit of a nightmare for this. Let's just have a look at the numbers. It's going to take me 4 to get to 1460 and another 40 to get to 1500. So 40 plus 4 is 44. 739 to leading digit means that's the digit we round to. This is what we have to do. So this is 0, 1, 2, 3, or 4. So that means we chop the end off and replace it with zeros. So 700 to the leading digit. Okay, this lots of errors with this one here. The smallest 3 square numbers are. All right, 1 times 1 is a square number. 2 times 2 is a square number, 4. 3 times 3 is a square number, 9. And that was your answer. Many of you forgot to use 1 as the lowest square number. When 651 is divided by 8, the remainder is, let's find out, 0. 8 eighths is 64, with 1 left over, 8 goes into 11 once, remainder 3. 3 is the remainder. All right, the lowest common multiple of 10 and 25. So 10 doesn't go into 25. 25, the next number will be 50, and 10 will certainly work its way up to 50. There's our lowest common multiple. 5 times 5 times 5 times 5 can be written in index form as 5 to the 4. This one here, many of you got this right, which is great. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. 16 and 9 is 25, plus another 4 is 29, plus another 1 equals 30. There it is there. Which of the following is true if A, B, and C are whole positive numbers? So usually with these ones, you have to just check the answers until you find something that looks right. So let's start with A. A plus B is the same as A take B. That's completely false. That's saying addition is the same as subtraction. No way. A take B is the same as B take A. That's false as well. Well, that is not true. All right, here we go. This is the one that is the correct answer. A plus, so if they force you to add these first, that'll be exactly the same as forcing you to add those together, because addition, 3 plus 2 plus 1, 2 plus 3 plus 1, both of these yield exactly the same result. It's going to be 6, which means order does not matter. Okay, many students struggled with this terminology of consecutive numbers. Consecutive things are one after the other, okay? Now that does not mean 5, 7, and 9 are consecutive, okay? Because they're not. Consecutive means one after the other, and what you've done is skipped poor old 6 and skipped poor old 8 here. They're not consecutive because you're skipping. So 3 consecutive numbers where the first number is 5. So the first number is 5, followed by 6, followed by 7. It's the only one that's an acceptable answer. 5 consecutive numbers are written on 5 different cards. So like many of you guys, I was really pleased to see you actually draw the cards. Some of the first 2 cards is 43. So that's going to be 21 and 22. Just a quick bit of trial and error there will produce 43 there. If they're consecutive, then that means that's 23, that's 24, and that's 25. So we're going to do 23, 24, and 25. We're going to add them together. 23 and 24 is 47, 57, 67, 72 is our answer there. Trains leave Flinders Street Station every 7 minutes, with the first train leaving at 6 a.m. Timetable is broken. Departures board reads 7 something. Give 2 possible train times. Now, many students wrote 7:07. No. If trains leave every 7 minutes, starting there, then what I'm interested in knowing is how many trains will leave before the hour is turned. Now, 7 times 8 is 56. So at 6:56, there will be a train, which means the first train after 7 is going to be 7:03, because I'm going to add 7 to that. The next one after that is going to be 7:10, and there's a number of different answers you could have provided, 7:17, 7:24, etc., etc. but that one and that one are the two correct answers. All right, magic squares. All right, now hopefully I get this right. I'm not the world's best at magic squares. Oh, this one's not too bad. So all rows, columns, and main diagonals add to the same number. So we just need to work out what the magic number is. 8, 13, 15. The magic number is 15. All right, so that means 9 and 5 is 14. 1 is 15. 8 and 1 is 9. 9 plus 6 is 15. 6 and 2 is 8. 8 and 7 is 15. 7 and 5 is 12. 12 and 3 is 15. 8 and 3 is 11. 11 and 4 is 15. Let's just check it out for one more. 9 and 4 is 13. 13 and 2 is 15. Okay. Got the numbers 1 to 6. All right. Okay. Arrange the digits so that each side adds to 11. Again, this is a little bit of trial and error here. So at the moment, it's adding to 8. So we need to get it to 11. So I'm going to pause this as I fumble around with it a bit. Okay, so what I'm going to do is pop the 6 there. Now 3 there. 6 and 3 is 9. 9 must have 2 added to it. 2 plus 5 is 7. 7 must have 4 added to it, which leaves the only number as 1, which is convenient because 6 plus 1 is 7. 7 plus 4 is 11. Okay, so don't be thinking I got that out straight away. I've just had to have a quick play by myself on a pad here while I've got this paused just to get that right. So you would have had to probably have a couple of goes at that, or you may have actually fluked it. Okay, we've got 3 people doing laps on a miniature railway track. Track is made of 2 different size loops as shown. Now it's possible to travel a complete lap using one or both of the loops. Okay, so you could do a complete lap doing that. You could do a complete lap doing that, or you could do a complete lap doing the whole thing like so. All right, so let's have a look. Alessia travels a complete lap measuring 33. We've got one person doing 36 and another doing 45. Now looking at that, 9 goes into both of those. Okay, so let's say that this track here could be 9. Now, Alessia on 33 means that this track here could be 11. So let's see what, is it possible to travel? So Alessia travels a complete lap measuring 33 meters. Okay, so it is possible to travel a complete lap using one or both of the loops. So let's just see. So I'm just going to suggest that Ali and Alicia travel on this one here, and what they do is 9. She does 4 laps, because 9 4s are 36. She does 5 laps, and Alessia does 3 laps of the 11. So that's one possibility. There were a few other possibilities. I think 15 and 18 was another one. Okay, so how to do 15 and 18? Well, 45 is just 3 laps of the 15. 36 would have been, how would I do 36? 18, 28, 33, that would have done 33. Oh, and 36 is just 2 lots of 18. So 15 and 18 was acceptable. 12 and 33 was another acceptable one. 12 and 21 were also acceptable. So it was a bit of a task. See how these ones were okay. But most of you who got the marks for that did use a 9 and 11 configuration. Right, and there's the end of the assessment solutions.